Hi there, my name is Dimitris Haralambidis, and in this video we will work on what is known as trigonometric ratios of an angle. To begin with, let's just say that the trigonometric ratios of an angle, which are 6 in total, but in this video we will focus on the 3 of them, the key 3 ones, sine, cosine, and tangent. The trigonometric ratios can serve as an angle's unique identity, meaning that each angle has a unique combination of these three ratios, which, by the way, are just numbers. We'll begin by defining the trigonometric ratios of an acute angle. And to do that, we will need a right triangle. So let me create a right triangle. We know, I'll name that as A, B, and C. And before we proceed with the definitions of sine, cosine, and tangent, we should talk about some basic terminology. We have seen that in a right triangle, we have a right angle, which measures 90 degrees. The side which is placed right opposite, sorry about that, the side which is placed right opposite this angle is called hypotenuse, and the other two sides are called legs. So we have this leg here and that leg here. And in order to make them be different, I'll call that as leg 1 and that by leg 2. Now, legs are further classified as opposite and adjacent. Depending, however, on the selected acute angle. What does that mean? This means that in the exact same right triangle, so I'm gonna draw two identical right triangles. This is 90 degrees, this is 90 degrees. If I select my acute angle to be this one, with regards to the naming of the sides, the hypotenuse is always the side which is placed right opposite the 90-degree angle, but from the two legs, the leg which is right next to the angle is called adjacent, while the leg which is opposite that selected angle is called opposite. If at the same time I select the second acute angle, yet again, this would have been the hypotenuse, but this time the opposite would have been this, while the leg that is connected to that acute angle would be referred to as adjacent. So we can only see that there's only one side that has a fixed name, and that is the hypotenuse. Why do I need to know this? Why do I need to be able to classify the adjacent from the hypotenuse? Because by using them, I will now be able to determine the sine and cosine. Let's take this angle and let's call that theta. And let's call the three sides by A, B, and C. So obviously C is the hypotenuse and A and B are the legs. The sine of theta which is also expressed in math language as sine of theta, is the quotient of the length of the opposite leg over the length of the hypotenuse. The cosine of angle theta, which is also notated by cos of theta, is the quotient formed by the length of adjacent leg over the length of hypotenuse. The tangent of angle theta, which is also notated by tan of theta, is the length of opposite leg over the length of adjacent leg. If I now want to apply these three in my drawn triangle, considering the angle theta, C is the hypotenuse, regardless of the angle theta actually. But with regards to the selected angle theta, B is the opposite, while A is the adjacent. So sine of theta, which is the ratio formed from opposite over hypotenuse, would have been B over C. Cosine of theta, which is the ratio formed by the adjacent over the hypotenuse, would have been A over C. And finally, the tangent of theta, which is the ratio formed by the opposite over the adjacent, is B over A. These three rules, and I'll show you why, are also referred to as SOH CAH TOA rules, because you see, SOH CAH TOA rules, where SOH CAH TOA is just a mnemonic way to remember them. SOH CAH TOA. And yet again, the S stands for the sine, the O stands for the opposite, and the H stands for the hypotenuse. Similarly, the C stands for the cosine, A stands for the adjacent, and H stands for the hypotenuse. And with regards to TOA, again, tangent, opposite, and adjacent. Are these three trigonometric ratios important in exercises? Yes, because similarly to the Pythagorean theorem, where we just had a theorem or a relation that connected the lengths of the three sides of a right triangle, here as well, we have three new such connections. This time, not only we connect sides to each other, but basically we connect two sides of a right triangle with one of its acute angles. Let's quickly jump to the exercises, to some exercises. And before we do that, I'm going to write here at the left these rules. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Let's see the examples. In the following diagrams, create equations. So that's all that it's asked from us, to create equations that combine the given information. Let's go with A. Let's see with what do I have. First of all, what I see is that I have the angle. And based on this angle, I have the hypotenuse, which is A. So I have hypotenuse. And based on that angle, I have the opposite leg. The opposite, which is the x. Which one of these three ratios? Is it the sine, is it the cosine, or the tangent? Which one of these three connects the given info? The angle, the hypotenuse, and the opposite. Angle, hypotenuse, opposite. Angle, opposite, hypotenuse. It should be sine. So these three are connected through sine. Let's express that in an equation. Sine of an angle, in this case sine of 65, would have been the ratio of the opposite leg, x over the length of the hypotenuse, x over a. Let's go to E. What do I have in E? I have the angle here, which is 49. Based on this angle, I have the opposite, which is E, and I also have the adjacent. Which trigonometric ratio? Is it the sine? Is it the cosine? Is it the tangent? Which trigonometric ratio combines angle opposite adjacent or angle adjacent opposite? By looking at the left, you will get used to that. By looking at the left, we do see that it's the tangent. The tangent connects these three concepts, an angle, the opposite, and the adjacent. So tangent of 49 degrees is the ratio formed by the length of the opposite, which is E, over the length of the adjacent, which is x. Let's go to G. What do we have in G? We have the angle, which is 54 degrees. Based on this angle, we have the opposite, and we have the hypotenuse. Which trigonometric ratio combines these three? Angle, opposite, hypotenuse. Again, it's the sine. With regards to the equation that needs to be expressed is sine 54 is equal to opposite, which is G, over the hypotenuse. Let's do K. What do we have in K? Again, we have the angle, which is 70 degrees. Based on this angle, we have the opposite, which is A, and we have the hypotenuse, which is x. Which trigonometric ratio combines these three? Angle, opposite, hypotenuse. Again, it's sine. Sine of 70 is A over x. Let's now go to the second. Let's go to these two examples in where we not only are asked to calculate an equation, but also to find a missing length. Again, however, we should begin by some investigation. What am I given? I am given the angle, 58. I am given the hypotenuse, which is 10. And although I'm not entirely given that, because that's what I need to find, I am somehow x is involved. But with regards to 58, which is my selected angle, x is the opposite. So opposite is the x. Which trigonometric ratio combines them? Is it the sine? Is it the cosine or the tangent? Angle, opposite, hypotenuse. It should be the sine. So let's form the equation. sine of 58, which is the sine of the angle, is opposite, which is x, over the hypotenuse. And now let's use the calculator. Most, if not all of these exercises will be done through the calculator. Our calculator is the Casio, the FX CG50. So I'm gonna go to menu, run matrix, option, calc, solven. Oh, I totally missed it. Calc, solven. So I'm gonna go to the solven command and I'm gonna write sine 58 equals x over 10. So sine 58 is x over 10. I'll press the X, ignore this exit. So x should be 8.48 degrees. Let's see the key parts. Investigation. What am I given? Which trigonometric ratio combines them? Form the equation and use the calculator. Let's apply that in the second case as well. Again, what am I given? I'm given this time the angle, which measures 39 degrees. This is the hypotenuse, which is placed right opposite the 90 degrees angle. So with regards to the angle of 39, 8 is the opposite. So I'm also given the opposite, which is 8. And I can see that x, which is the adjacent, is also involved in all that. This is the adjacent x. Which trigonometric ratio, let's remember the rules, which trigonometric ratio connects an angle, its opposite leg, and its adjacent leg? Angle opposite adjacent, it should be the tangent. It's the tangent. Let's form now the equation. We know the tangent of an angle. So in our case, tangent of angle 39 should be the ratio formed by the length of the opposite, which in this case is 8, over the length of the adjacent, which is in this case is equal to x. I have the equation. Now I'll go to the solven command in my GDC or the nsolve if you're using the TI, and I'm gonna plug it in. Tangent of 39 equals 8 over x. X, it should be 9.88. X equals 9.88 meters this time. The previous one, it wasn't degrees. Sorry, I just realized that it was as well cm. So that was cm. And in our case, these were meters. And that would be all. Remember, the key parts of this video. You need to remember the SOH CAH TOA rules. In order to define the sine, we need the opposite over the hypotenuse. In order to define the cosine, we need the adjacent over the hypotenuse. And finally, in order to define the tangent, we need the opposite over the adjacent. Once you have them, remember that apart from these three being the angles identity, they are also at the same time relations that connect two sides and an angle, which means that if I know the two sides, I will be capable to calculate the angle. If I know one side and the angle, I will be calculate the second side as well. How do we act in exercises? We always begin. What is the given information or the implied information, whether it's an x or an actual given value? Which trigonometric ratio combines this info? form the equation, and finally use your calculator. I hope it helped. If you have any questions, please don't be shy. Leave your comment below the video. As always, thank you for your time.